So I hope you will enjoy this last piece very much.
This is R3D2, my ES50 final project. R3D2 is an autonomous object-avoiding robot that can navigate around spaces containing large obstacles without bumping into those obstacles. I decided to name the robot R3D2 because it was supposed to look like R2D2, the only not uncool three-legged robot that I know of, and also because the microcontroller that powers it is called the ESP32. There are two motion sensors mounted 135 degrees apart in R3D2's head, which provide input to the decision-making code that runs on the microcontroller. Based on the decisions that the robot makes, the microcontroller provides output to the motors that control its motion, causing the robot to turn left or right or move forward or backward. There's also a servo in R3D2's neck, which allows the head to rotate back and forth along a 135-degree arc. This, combined with the fact that the motion sensors are mounted 135 degrees apart, allows R3D2 to have 270 degrees of vision with a single 135-degree turn of his head. Here's R3D2 with all of its body panels attached. I built the body from scratch out of foam poster board and glue on my dining room table over the course of a very long time. It was incredibly time-consuming, but in the process, I did get really good at doing trigonometry and cutting poster board. As you can see, my cat was also very interested in this process. She was also very interested in the robot once it was built. Notice that in this video, when she gets very close to one of the sensors, which she is about to do, R3D2 turns away from her. So she gets close to the sensor right here, and the robot turns to the right. Here's a better demonstration of R3D2's object avoidance capabilities. R3D2 alternates between scanning its surroundings and searching for objects immediately in front of itself. When it's standing still like this, it's searching for objects in front of itself. Then when I put the notebook in front of it, it switches into scanning mode in order to find a different path. Here we can see that I put the notebook in front of it yet again. In this next clip, we can see that if I simulate the presence of an object on the right side of the screen, when R3D2 switches into scanning mode, the robot decides to turn toward the left side of the screen in order to avoid it. The opposite is then true when I simulate the presence of an object on the left side of the screen. This functionality doesn't work quite as well in the wild, as it were, because I built the body before I received the electronic components, and I forgot to consider that the distance sensor eyes would not be parallel to the floor. Long story short, this basically prevents the distance sensors from behaving correctly. But overall, this was a very fun project to work on. Thanks, ES50.